All right, so the first thing that we want to do with equations like this is find what we want to be our ultimate equation. So that's going to be this one right here. And notice here that we have NOs and Os on the left side of the equation, on the reactant side, and NO2 on the right, or the product side of the equation. So given the information here, we can see right off the bat that not all of these correct products and reactants are on the correct sides. So I went ahead already and kind of put them on the correct sides down here, and literally all I did was switch two of the equations, and it was these two here, because notice that O is supposed to be on the left side, and forgive me, O2, these are going to need to cancel out, so they're going to have to be on opposite sides of the equation. So knowing that, I went ahead and flipped those, and I left this equation here alone because you can see that NO2 is already on the correct product side and NO is already on the reactant side. So this equation right here is okay. Notice also that when I went ahead and flipped these equations, I needed to reverse the signs of their enthalpy values. So again, this one stayed the same. However, this one I made a negative value instead of the positive value it was up here. And this one here, I made a positive value instead of the negative value that it was. Now the next step that we're going to have to take is we're going to have to multiply this whole equation by 2. Because notice that if we don't multiply it by 2, things aren't going to cancel. And that's our ultimate goal, because we don't ultimately have all of these things in our final net equation. So these things on the product side are going to have to cancel with things on the reactant side. So here, that will give us 2 O2s, 2 NO2s, 2 NOs, and 2 O3s. And notice now we are pretty much good to go. So once we multiply these, you can see that we have 3 O2s on the reactant side now, because we have 1 from this one here, 2 from this one here. So those 3 O2s are going to cancel with this one here. The 2 O's are going to stay the same, and so are the 2 NOs, but this 2 O3 here can go because it can cancel with this one here. So now notice what we have. We have 2 NOs, 2 O's, and 2 NO2s. So let's go ahead and add up our values. And remember, we multiplied this whole equation by 2. So our new enthalpy value, let me use my calculator here, is going to be negative 398 for this equation here, because we multiplied it by 2. So now we can go ahead and add all these together. And once you add up negative 398, negative 495, and 427, it gives us a net value of negative 466 kilojoules. But we're not done quite yet. Notice here that our net equation only has the coefficient 1 in front of each of the reactants and products. So we need to divide this value by 2. And that's going to give us negative 233 kilojoules, of course. And that is your enthalpy value.